The battery war just took a dramatic turn when Elon Musk responded to Sawyer Merritt's explosive tweet claiming the importance of Tesla's domestic battery production in the USA. In less than 24 hours, this single tweet turned into a storm because what Musk hinted at is no longer a distant dream. It's happening. It has a name, and it's called NC5. That's not just a lab prototype. It's now officially being tested on Tesla 2026 Model 2. And it may be the final puzzle piece Musk needed to fully Americanize the EV supply chain. Cathode, anode, lithium, everything. And as Musk hinted just days ago, making the most efficient cell in the world. We're also investing in the whole battery supply chain. So we have cathode production, we have lithium refining, and then more. But what makes NC5 truly all new to be the end of China's dominance? Other headlines have mentioned this battery for a long time, but none of them bring the truth of its definition, architecture, and promising features. So if you're as curious as we are about what's inside Tesla's secret new battery, stay right here. 1. How all new is Tesla NC5 battery? The Tesla NC5 is a complete revolution disguised in battery development. NC5 stands for nickel-based compact cell, 5th generation, and it represents Tesla's most audacious engineering gamble yet. Tesla has been secretly testing this technology at Giga Texas since the third quarter of 2024, away from prying eyes and industrial espionage. And the all-new designation signals a fundamental shift in Tesla's manufacturing philosophy that abandons everything they've built before. Here's where it gets explosive. Tesla is ditching their famous cylindrical 4,680 cells entirely. The NC5 switches to a rectangular prism architecture that sounds boring until you see the numbers. Energy density jumps to 310 watt-hour per kilogram, crushing the 4,680's measly 260 watt-hour per kilogram and obliterating Chinese competitors like CATL, who struggle to break 250 watt-hour per kilogram. This isn't incremental improvement. This is technological dominance. That 310 watt-hours per kilogram translates directly into 300 miles of range for the Model 2, while BYD's Seagull limps along at 190 to 250 miles. The math doesn't lie, but the real bombshell is the cost revolution happening inside these cells. Tesla's dry electrode coating technology slashes production costs by 40%, while cutting battery pack completion time by 30%. This is economic warfare against China's manufacturing advantage. The advanced tabless design refines the 4,680's breakthrough technology for smaller NC5 cells, reducing internal resistance by 15% and enabling 10-minute charging from 0 to 80%. Meanwhile, the dry electrode technology eliminates toxic solvents entirely, cutting production costs by another 10 to 15% while destroying China's wet process dominance. Tesla is literally making Chinese manufacturing methods obsolete. About the engineering specifications, the NC5 uses modular design, reducing the Model 2's weight to 3,200 pounds, compared to BYD Seagull's 3,500 pounds. This shows a 10% weight reduction that compounds into massive efficiency gains. Operating temperature range expands from the current negative 20 degrees Celsius to plus 50 degrees Celsius limitation to an incredible negative 40 degrees Celsius to plus 65 degrees Celsius, making these batteries functional in extreme climates where Chinese competitors fail. Most shocking of all, cycle life extends to 2 million miles compared to the current battery's 500,000-mile limitation. These are test results from Nevada and Texas facilities. Tesla's localized production strategy in Nevada and Texas represents the ultimate checkmate against China's resource stranglehold. By reducing reliance on cobalt and nickel while implementing AI-driven manufacturing, Tesla's gigafactories could achieve 20% higher throughput than CATL's factories. The target is 100 gigawatt-hours of NC5 production by 2027, which is enough for 1.5 million Model 2 vehicles annually. This isn't just about making batteries. It's about making China's battery empire irrelevant. So, how all new is the NC5? It's not refinement. It's not a refreshed version of the 4,680 battery cell. It is a total reset as Tesla's secret weapon to win the EV race. Not by building bigger, but by building smarter. If China built the factories, Elon Musk just rewrote the playbook. And now, he's testing it in the one car that could reach every American driveway, the Model 2. Do you think this battery truly deserves the name all new? Or is that not bold enough? Drop your answer in the comments with just 2 words. All new. If you believe this battery changes the entire game. But that raises a much bigger question. If the NC5 is this advanced and new, then what happens to BYD? What happens to the Chinese EVs that once led the budget EV race? 2. How is NC5 a technological threat to BYD? Meanwhile, North America had 0 significant graphite mines in 2023, and Canada managed only 1% of global production. This stranglehold gets even more suffocating when you realize that 80% of the world's batteries still require synthetic graphite from China. BYD leverages this dependency ruthlessly, dominating the global LFP lithium iron phosphate battery market with 41.1% market share while competitors scramble for Chinese-controlled materials. But Tesla's NC5 just shattered this monopoly with surgical precision. Instead of playing China's rigged game, Tesla rewrote the rules entirely. The company signed strategic agreements with Piedmont Lithium and Albemarle, both American companies, to develop battery materials that comply with the 100% localization policy under the Inflation Reduction Act. This isn't just smart business, it's economic warfare. Tesla's nickel supply comes from Canada through the Giga Lathrop joint venture and Indonesia through partnerships that deliberately bypass Chinese-controlled supply chains. Every ton of material Tesla sources independently is a direct attack on BYD's fundamental business model. The most devastating blow comes from Tesla's partnership with California startup Sila to develop silicon anodes using domestically sourced silicon powder, according to Wired's reporting. This technology increases battery range to 500 miles while shortening charging time to 10 minutes, numbers that make BYD's current offerings look prehistoric. Silicon anodes increase capacity by 20 to 25% within the same cell volume while improving cycling stability, resulting in longer battery life and higher performance. BYD built its dominance on Chinese graphite dependency, but Tesla just made graphite irrelevant. Here's the knockout punch that proves NC5 is a technological revolution. Cattle's best batteries still take 45 minutes to charge 80%, but NC5 drops that to under 15 minutes. This isn't incremental improvement, it's a complete paradigm shift. The NC5's dry cathode technology, combined with silicon anodes and a rectangular cell design, allows charging 5 to 3 times faster than anything BYD currently produces. When integrated with Tesla's optimized battery management system design, NC5 reaches 80% charge in less than 10 minutes. A performance leap that makes BYD's LFP technology look like outdated engineering. BYD's entire competitive advantage evaporates when Tesla no longer needs Chinese materials, Chinese manufacturing expertise, or Chinese supply chain dominance. The NC5 doesn't just compete with BYD, it makes BYD's core competencies obsolete. While BYD optimizes yesterday's technology using tomorrow's material shortages, Tesla engineers tomorrow's technology using today's abundant American resources. This isn't competition, it's technological annihilation disguised as innovation. If Tesla no longer needs Chinese graphite, doesn't rely on Chinese nickel or cobalt, and is charging 3 times faster than CATL, can we officially say this is the end of China in the battery game? If you believe NC5 is the turning point we've all been waiting for, drop the phrase "end of China" in the comments right now. Let's see how many of you are ready for a battery world that's built on independence, not dependency. But we're just getting started, because if NC5 is this powerful on paper, what happens when Tesla starts testing it inside the 2026 Model 2? 3. How appealing is Tesla testing NC5 battery for Model 2? When Elon Musk says something is finally here, he's rarely talking about the past. He's talking about a tectonic shift that's just begun. And when it comes to the NC5 battery, finally here isn't a marketing phrase. It's a major technical milestone. This new battery is now in active pilot production, undergoing Model 2 specific engineering workflows from thermal simulation to mechanical integration. That means NC5 is no longer a lab concept or a theoretical leap. It's physically being built and tested inside Tesla's production pipeline, preparing to power the company's most important vehicle yet, the sub-25,000 Tesla Model 2. The timing of this rollout is no coincidence. Tesla is pushing to hit 90% dry cathode manufacturing yield by the fourth quarter of 2025, and that target is not arbitrary. It directly aligns with Tesla's historical pattern of assigning new cell architectures to game-changing vehicle launches. Do you remember when the 4,680 cells first appeared in the Model Y? Or the dry cathode variant being built into the Cybertruck? Tesla always tests new formats quietly, then drops them into high-volume builds when the tech is battle-ready, and all signals, including Elon Musk's repeated mentions of localized supply chains, the silence-breaking tweets that we show you in the opening of this video, and even leaked Battery Day documents, are pointing to NC5 being tailor-fit for the Model 2 launch cycle. So where does that put us now? Based on factory whispers and supplier activity, Tesla is expected to start early validation builds of Model 2 with NC5 in Texas or Fremont between Q1 and Q2 of 2026, possibly even extending to Giga Shanghai, depending on regulatory flexibility. By late 2026, The first full-scale units may roll off the line with NC5 cells standard from the factory. And here's the genius. Using NC5 in Model 2 allows Tesla to slash battery costs. Hit that critical sub-25,000 price point, and fully qualify for government incentives. Something foreign rivals like BYD simply can't compete with. So if you're still wondering whether NC5 is really here for the Model 2, the answer is an emphatic yes. It's under test, under refinement, and under wraps. But its arrival is just a few production quarters away. By the time the public sees Model 2 in showrooms, the battery revolution inside it will already be quietly underway. And this is no hype. This is how Tesla changes the game. Not with press releases, but with factories, firmware, and forward planning. So how close do you think we are to seeing the first sub-25,000 EV powered by a battery that charges in under 15 minutes? Drop a number in the comments section. 4. Why should traditional automakers be extremely worried, while Ford, GM, Volkswagen, and Hyundai still lean heavily on Chinese technology? Tesla is quietly sprinting ahead with a vertically integrated American-led battery strategy that cuts costs, increases speed, and completely sidesteps foreign control. Take Ford, for example. Its lithium iron phosphate plant in Marshall, Michigan, may be 60% complete, but it's still licensing critical technology from CATL, which means it's anchored to Chinese intellectual property. GM isn't far behind in vulnerability, still bound by long-term supply deals with LG Chem, whose raw materials largely flow through Chinese processing hubs. Volkswagen and Hyundai remain deeply dependent on CATL and BYD for battery packs, with no US-controlled supply chains to fall back on. That exposes them to every pressure point: tariffs, executive orders, rare mineral export bans. And perhaps most devastating is the exclusion from Inflation Reduction Act incentives worth $7,500 per vehicle. Meanwhile, Tesla is in another situation, with NC5 already in pilot at Giga Texas, reportedly producing over 25,000 test packs and a 20 gigawatt-hour dry cathode line ramping in Lathrop. The company is miles ahead. By late 2025, Tesla targets a dry cathode yield of 90%, up from the 20-30% in early 4,680 cells. That's not just a manufacturing flex, it's a cost weapon. Tesla is on track to cut battery costs per kilowatt-hour by 30% versus current Chinese-sourced formats. Combine that with under 10-minute charging, domestically sourced lithium and nickel, and full IRA compliance, and Tesla now controls the four legacy automakers desperately lack: speed, scale, subsidy, and supply resilience. And here's where it gets lethal. Traditional OEMs are now caught in what you could call a cost trap. They're paying 30-40% more per cell, facing expensive overseas shipping, and losing out on tax credits. Tesla, meanwhile, can undercut them on pricing by 15-20% on the final vehicle, while maintaining higher margins and production stability. This isn't just a market shift, it's an industrial collapse waiting to happen. For China, for legacy automakers, and for every driver who's been waiting for an affordable EV that doesn't compromise on range, speed, or independence. This is the beginning of the end of China in batteries. But if NC5 delivers on even half of what it's showing now, it won't just disrupt the industry. So if you find this video eye-opening, drop a comment below with the words, "Tesla wins," so we know you're part of the movement that sees what's coming before the rest of the world does. Thanks for tuning in.